this video, we're going to take a look at solving some multi-step equations and inequalities. So we're going to bump up the complexity just a little bit. So here's an example of a multi-step equation that we're going to try to solve. I should probably have instructions up here so we know what we're dealing with. We're trying to solve. So the goal that we should have in mind, and I'm going to use one of my strategies here of highlighting the variable that we're trying to isolate, is this is the variable x right here, and I want that to be the only thing on the left side. I don't have any variables on the right, just that one on the left. I want that to be the only thing on the left. So we've got all this other stuff going on that we're going to have to get rid of at some point. And I'm going to use my other strategy as well of separating the left side from the right side. And this is especially important because we have a more complicated equation, so I just don't want to get mixed up that anything I do to the left, I want to make sure I'm also doing that to the right. So there's a lot of flexibility that you have in solving this equation. So I don't want you to focus on the idea that there's a specific set way that you have to go about this, that there's a correct first step and a correct second step. There's a lot of ways that you could do this. So we're going to solve this one in a few different ways. The first thing that I want to notice about this is even though this expression here, 3 times this quantity 2x plus 5, it's kind of complicated. That's just one thing from which we're subtracting 1. Being successful at algebra a lot of times is going to involve looking at a problem that's complex and kind of simplifying it for yourself. So I don't want to look at this as 3 times the quantity 2x plus 5 minus 1. Right now, I want to just look at this and think about it as I have something minus 1. And I want to get rid of this minus 1. Well, what's the inverse of subtracting 1 but adding 1? So I'm just going to add 1 to the left. Got to make sure that I also add 1 to the right. On the left side, I have minus 1 plus 1 is 0. So all I'm left is with this something. So I'm just going to bring that down. It happens to be 3 times the quantity 2x plus 5. Bring down that equal sign. And bring down 62 plus 1 is 63. And so I've gotten rid of that minus 1 by doing the opposite, and I brought that something down. Now there's a couple ways we could go about this from here too. You could maybe think about distributing the 3 and seeing what you have. But when I look at this, I see that I just have 3 times something equals 63. So I want to get rid of that 3. I have 3 times something. I just want to know what that something has to be equal to. So I have 3 times something. The inverse of multiplying is to divide. So I'm going to divide that entire left side by 3 and the entire right side by 3. So let's see. 3 divided by 3 is a 1. So now I only have one of these somethings. So I'm going to bring that down. It happens to be 2x plus 5 is that something. And it's equal to, bring down that equal, 63 divided by 3. Let's see, what's that, 21? Alright, now in this step I have these parentheses around the 2x plus 5, but since I'm not multiplying anything on the outside anymore, I don't really need those, so let's go ahead and drop those parentheses. There's no need to group it together anymore. It was needed up here because we had 3 of this whole thing, but now I just have 1, so it's 2x plus 5. I'm still going to highlight this variable that I want x by itself on the left. So let's get rid of the plus 5. I want to do that first. So the inverse of adding 5 is subtracting 5. On the left side, 5 minus 5 is 0, so I have 2x equals, go ahead and bring that down a little bit. 21 minus 5 is going to be, what's that, 16? So let's see, I still have this 2 to deal with. I have 2 times x, the inverse of multiply is divide, so let's go ahead and divide both sides by 2. Well, 2 divided by 2 is 1x, bring down the equal, 16 divided by 2 is 8. Now I have variable equals number, so I know that I'm at my solution. Now I don't think I made any mistakes along the way, so let's go ahead and substitute this in to check it. So if you take 3 times, let's see, 2 times 8 plus 5 minus 1, we should get 62. Well, starting inside here, 2 times 8 is 16, plus 5 is 21, so 3 times 21 is, whoops, why did I make that 61. 3 times 21 is 63, and 63 minus 1 is 62, so 8 is the solution. Graphically, this is going to look like a number line with 8 on there, and maybe one above, one below. I want to show that only 8 is the solution. X is just equal to 8, so a closed circle. We'll do that, and that one's finished. Now I want to go back because there's a lot of different ways that you could have solved this. So let's go back to the original. We have 3 times 2x plus 5 minus 1 is equal to 62. And I think what a lot of students would do first with this is to distribute that 3. So I have 3 of this quantity. So I have 3 2x's making 6. And I also have 3 5's. So when you distribute, you are multiplying in. 3 times 2x is 6x. 3 times 5 is 15. And let's see. So we're trying to isolate this x right here. Get that guy all by itself on the left side. Let's go ahead and highlight our left and right. Why not? Now take a look at what you have on the left side. Well, I have a couple of things that I know I can combine together. I have a 15 minus 1. And those are like terms because they do not have a variable. They're just plain real numbers. So I can combine those. So 15 minus 1, I'm going to go ahead and just combine those together into one number and just have 14. All I'm doing is just, these are two numbers, they're on the same side, I'm just organizing them together. Let's bring down that 6x. That's going to be positive 14 because the 15 is bigger and it's positive. Equals 62. Let's see, let's go ahead and get rid of that plus 14. Let's highlight that variable again. Yeah, I got that 6 and that 14. Well, the inverse of addition is subtraction, so let's go ahead and subtract 14. 14 minus 14 is 0, so I have 6x. Bring down the equals. 62 minus 14 is going to be, what is that, 48? I have 6 times x, so I'm going to divide both sides. It's the inverse of multiplying. I have x all by itself on the left, and 48 divided by 6 is 8 on the right. And we already checked it, that one is correct. So there's nothing wrong with solving it this way, and there's nothing wrong with solving it this way. You have a lot of flexibility when it comes to algebra, as long as you are making sure that you do the same thing to both sides, make sure that the step actually does what you think it does, and keep an eye out for when you have quantities and just looking for structure in your equations. Let's take a look at another one that involves having more than one of the same variable on the same side. Let's do an inequality. So let's go ahead and solve this inequality. Let's say we've got, I don't know, 5n plus 3n minus 16 is equal to, I don't know, let's say 24. So I'm going to go ahead and draw those lines, highlight the left and right side, so I know that anything I do that side, I got to do that side. Anytime you have more than one term on the left side that is a like term, and when I say like term, I mean same variable, same power, you can combine them together. It's just like I have $5 bills and $3 bills, and I just want to combine them together into one pile. So instead of having two piles of n's, I just want to combine them into one. Well, I have 5 here and 3 here, so I'm just going to combine those together into one pile and make 8n. The minus 16 is not a like term because that does not have an n. That's just a plain real number where that's a variable term. So let's keep those separate. Equals 24. I said we were going to do an inequality. Let's make that a greater than or equal to. Okay, there we go. Now I want to get this n all by itself on the left side. So I've got that 8, I've got that 16. Go ahead and divide first. Why not? If I'm going to divide this entire left side by 8, I have to divide that entire right side by 8. So I'm going to divide the left side. 8n divided by 8 is 1n, and minus 16 divided by 8 is minus 2. Is greater than or equal to 24 divided by 8 is 3. Since I divided by a positive number here, there's no need to flip that sign. It stays greater than or equal to. I have to undo this subtraction of 2 with the inverse, which is addition of adding 2 to both sides. Negative 2 plus 2 is 0, so I have n all by itself. Greater than or equal to 3 plus 2 is 5. Graphically, I'm going to have 5. Let's go ahead and put a 4 and a 6 on there. Let's see, it can equal 5, so let's have a closed circle on 5. On the direction the numbers are bigger than 5 are to the right, so anything to the right should work as well. If you go back and check, we would have, let's see that boundary, 5 times 5 minus or plus 3 times 5 minus 16 is greater than or equal to 24. Well, that's going to be 25 plus 15 minus 16 is greater than or equal to 24. Let's see, that's going to be 40 minus 16 is 24 is greater than or equal to 24, and it worked. Let's go ahead and pick 6 to also check that the arrows go in the right direction. So we have 5 times, let's see, 6 plus 3 times 6 minus 16 is greater than or equal to 24. Well, that's 30 plus 18 minus 16, greater than 24. So what's that? 48 minus 16. Let's see, 48 minus 16. Minus 16, is that 32? 32 is greater than or equal to 24. That's absolutely true. So that boundary is good, and that arrow direction is good as well. So some things to look at when you're solving multi-step equations. You might have to deal with combining like terms, same variable, same power. As long as they are both on the left or both on the right, you can combine them. Take a look at places where you can distribute into quantities and then maybe combine afterwards. Take a look at trying to do opposite operations. Seeing this whole quantity as just one object helps us get rid of that minus 1. So look for structure in your equations as well.